In this video, we're going to be going over atomic structure, beginning with the atom. The atom is the smallest unit of constituent matter. It's what makes up everything around us. Now, taking a look at the periodic table, we notice that there's all of these different elements. Each of these elements is made up of atoms, but the atoms vary in exactly the number of each of the particles that they contain. These three particles are protons, neutrons, and electrons. So protons, neutrons, and electrons. Now, if we look at one of these examples, we're going to take a look at the element helium. So helium is right here. And if we scroll down, we notice that it has an atomic number of 2 and a mass of 4. What the atomic number tells us is the number of protons and neutrons, or protons and electrons, excuse me. So protons, P plus, and electrons as E minus. The 4 right here is its mass in AMU, and this gives us our protons plus neutrons. So 4 would be our 2 protons plus whatever's left over to make that number of 4. So then if we have an atomic number of 2, we know there's 2 protons, and we know the mass is made up of protons and neutrons. So the remainder would be 2 neutrons. Now, if we take a look at the atom itself, we notice that in the middle, there's the nucleus. This is made up of protons and neutrons, and it will have an overall positive charge. So protons and then neutrons. Neutrons have no charge. On the outside, there's an electron cloud filled with electrons. These electrons have a negative charge. This proton that has these protons that have a positive charge will attract the negative electrons, and this is known as an electromagnetic force. The force that keeps the neutrons and the protons together is known as the nuclear force. Now, if we go down, although electrons and protons have similar or balanced equivalent charges, the positive of the proton would cancel the negative of an electron. The weights of these three particles varies drastically. So if we scroll down to the parts of an electron right here, let's write them again. So we have proton, it's also P positive. It has a plus charge, plus you could think of it as +1, and then it has a weight of 1 AMU. Then we have neutrons. That have a charge of 0 and also weigh 1 AMU. And you can remember this because if we go right here, we had the 2 protons, we had the 2 neutrons, and that was a total of 4. So 4 AMU total in weight. And then finally, we have the electrons. And this will be E minus. And this will be a negative charge. And the weight of the electrons is significantly smaller than that of the protons and neutrons. The electrons have a weight of 0.00054 AMU, which is drastically smaller than the weight of the neutrons and protons. And if we take a look at a picture that represents the atom, what we see is that right here in the middle, you have the nucleus with the protons and neutrons. And then in this giant cloud, you would have electrons spinning around the nucleus. So as you can see, it's very, very, it's filled with a lot of space. It's empty space. And then the electrons are spinning in here, while the protons and neutrons with significantly greater weights are right in the middle. And then also one additional thing, if you noticed up here, the mass that we see for helium is not exactly 4. It's 4.0026. And this is because this value is an average. It's not an exact value. It's the average of the weights of helium atoms found out in the world. So not all helium atoms will have the exact same weight, as goes for other elements. They will not all have the exact same weight. And this is because the number of neutrons is sometimes a little bit greater or a little bit less than the value we would expect. And that's why we put an average. But since the average is so close to 4, you know that most of the helium atoms out in the world are going to have a mass of 4, but then there will be some with a mass greater than that.